you all being back on. We're going to have a great set of classes today. We had a little bit of a shuffle on the presentation, so got a really good lineup, though, as listed here on the slide. Going to be giving folks who have a little more time than we thought between sessions, so we're going to kind of let presenters take some time for Q&A. So if after any of the sessions you have some questions, feel free to ask them. So for those of you that may be joining virtually that aren't in the DC area, we're the Washington Area Informix User Group. Tom Beebe, I'm president. Rhonda Hackenberg's here, vice president. Lester Knutson is on, who helped found the thing. So we have a lot of people on. I see some very friendly faces on the list who are regular attendees. For the time being, with the way the world is, we're going to stick virtual. That way we also can reach out to a larger audience. We're hoping somewhere in the nearish future we could look at doing some in-person training and meetings again. But right now we don't have a hard timetable on that. The other thing is we are a users group. This is not top down, we're ruling with an iron fist. This is a group that we are interested in or even dedicated to Informix, to getting help ourselves, to help others, to help educate, or just be part of a community. We've got a mailing list if you want to see what's going on. I promise we do not send many emails, just a few a year, mostly about our upcoming talks. We are also always open if anyone on here wants to give a talk or has things they are looking for and want more information about. It is a user group. We want to, feedback is a good thing. Feel free to reach out to any of us. Contact info is on the website. So we're all readily available. So, it's out there. We'd love to have you take more part in it. So what we're going to do is we're going to start out with Art Kagel, who's doing Storage Better, and he is presenting on doing Storage Better. Just wanted to double that one up. He is also going to be doing a bonus small presentation a little later today on creating Oracle-style global temp tables. This is a brand new talk. He's got some information coming out in the next issue of The Insider. If you're not part of the WAIUG, go sign up. All of this is free. So we are here to support the Informix community. So the Insider is the regular newsletter the IIUG puts out, really useful info, see what's going on, get information about all kinds of Informix stuff. So if you don't get it right now, go sign up for it. I promise none of us will clog your inbox with a whole bunch of emails. At any rate, I am going to turn this over to Art to hop into his presentation. And again, I want to thank you all for being here. I know this is early in the morning, especially for some of the folks not on the East Coast, but we don't want to take up your full day. So thank you, and I'm going to stop sharing so Art can pick up.
All right. Good morning, everybody. So this is a presentation that I've done several times. There is a little bit of new information. I'm always going back to this one and trying to find new information and new things to talk about. But it is primarily the same presentation. Let me see if I can get the share going. You cannot share content. Oh, you guys didn't make me presenter. I am now presenter. Okay. All right, so I'm going to put the, did everybody see the presentation? Tom, it's coming up.
It's not coming up yet.
Okay. Let me change that. No, it says, let's try this again.
Okay, now I'm seeing it.
Okay, so now we should be back here at the presentation.
Yes.
Okay. I'm going to put this in presentation mode. Let me know if it doesn't show up. It sometimes doesn't.
All right.
Where is the little icon to do that? There we go.
All right. See it in full screen now.
Perfect. Okay. So we're talking about different of I/O and storage and how to do that the best way possible for Informix. Um, and just a little bit of review. Prior to version 11, 11.10 specifically, when Informix opened a cook device or a file system, file-based chunk, it had to open it in OSync mode, basically synchronous I/O. So everything would be written to the file system cache and then flushed to disk, and Informix wouldn't get a response back from the write statement until the flush completed. And that kind of was one of the reasons why file system and cooked file IOs were relatively slow. Cooked devices could be 10 to 15% slower than raw devices, and file system chunks could be as much as 25% slower than raw. So back in the day, we all used raw. But with 11.10, we were able to support the O direct flag opening up file system chunks, and that bypasses the operating system cache. It doesn't bypass all of the overhead of file systems, but still, that cost is typically less than 5%, somewhere between 3 and 5% on most systems, and that's a whole lot better than up to 25%. And so at this point, I think we're pretty much um, um, split between people doing O direct and using raw disk um, file system chunks and raw disk. Okay. In 11.50, IBM added support for AIX concurrent I/O mode on JFS2 file systems, and that allowed for more parallelism between multiple sessions, and that improved performance on AIX. Okay. And in 14.10, we recently added the ability to use direct I/O on temp DB spaces by adding the for flag to the direct I/O on config parameter, in addition to the 1 or 2 for AIX. Okay, so that out of the way. Let's talk in general, right? There are three kinds of file systems. There are normal old-fashioned file systems. There are what are called lightweight file systems. And most modern file systems are journaling file systems. And so let's talk about that a little bit. File systems in general, when Informix allocates space for a chunk, it pre-allocates the entire chunk, right? So you don't end up creating a file that's empty. It actually tries to write to every page in the new chunk in order to make sure that the file is not created as a sparse file in the operating system. All right, and so that means that at least logically, the file is contiguous. But when the file system allocates a new file, it's going to put that together from multiple extents on disk, similar to the extents that are added to a table or an index in Informix when a table grows, right, or an index grows. And those extents may or may not be contiguous and may or may not be large. And that's going to depend on how fragmented the file system is when the new file is created, and whether the file system can find a single extent that's large enough to create the entire file out of. And if you have your tables, your chunks marked as extendable, right, so or expandable so that the chunk itself can grow when it fills up. Those new bits of disk space that are added or appended to the file may also not be contiguous. And you have no control over how the file system lays things out, right? So that's one of the reasons why we want to make sure that when you create file system chunks, and DB spaces, that you do that on file systems that are dedicated to Informix, A, and B, have no other files on them, and preferably have a single file on them, right? Just the one chunk file that grows by itself, or if you're using storage pools, to create a large storage pool file that encompasses the entire disk, the entire file system, so that everything in that storage pool, or that's allocated from that storage pool, is contiguous, at least within the one chunk allocation. Okay, so let's talk about file systems directly. Normal file systems have average overhead. Obviously, they're different file systems behave differently, but that's our baseline for the behavior of file systems. Um, and as I alluded to, most Unix file systems do try to allocate disk and new files from contiguous space, but again, there are no guarantees. There are things called lightweight file systems, but they're generally designed by SAN vendors or OS vendors for particular applications. They're supposed to be lower overhead than normal file systems, but pretty much without exception, the main um, acceleration that they put on those lightweight file systems is the ability to open and close files much faster. And since Informix only opens its chunk files once at startup, um, that has no effect on performance for Informix. So there's no gain to using lightweight file systems. Um, okay. Journaled file systems add a form of logging to a file system that reduces recovery time, limits data loss if the system crashes with unwritten data in the cache. And in general, the main advantage for um, journaling file systems in general is when you boot your system up, it rarely needs to go through periodic cleaning like non-journal file systems do, because the journaling maintains the file system in a consistent state even after a crash. You may lose some recently flushed data depending on the file system, but the file system itself is at least consistent. Okay. There are many different kinds of journal file systems. IBM created the JFS file system and JFS2, which became OpenJFS when it was released as open source. That is available on most Linux systems as well as AIX. ZFS, which is a Sun file system, also was released as open source shortly before Oracle took over. ext3 and ext4, of course, are the original native Linux file systems. Um, VFX is Veritas's lightweight journal file system, and XFS was developed by Silicon Graphics for the IRIX system, and is available on Linux systems as well. And there are newer ones like Ryza FS and Nova, a couple of others. Um, but let's look at these standards that are common on Linux systems and other Unix systems. JFS journals metadata only, not the contents of the files. And it serializes writes to maintain data consistency unless concurrent I/O is enabled, which is why direct I/O in Informix 12 was enhanced to support concurrent I/O on AIX, so that the multiple oninits could be writing to and modifying the metadata concurrently instead of queuing up and doing it serially. It allows for variable length extents to build large files. That's a good thing in general, but in the case of Informix, it may mean that chunks are created or appended to from smaller bits of non-contiguous space. And JFS locks the file allocation groups during file expansion. So when a file grows, nothing else can modify the file allocation for any file that's on that file system group, that allocation group, which is another reason, especially in JFS, to make sure that only Informix is using a particular file system, and you have as few files, a few physical chunks on there as possible, right? One big file, perhaps. It's fairly low overhead, and it's fairly safe as a file system. ZFS was built by Sun, as I mentioned. It uses a copy on write transaction mode. So when you rewrite a block of disk, the data is not overwritten in its original location, but is moved to copied to a new block, and then eventually the old block is put on a dirty list and is cleaned by background threads. So essentially, your chunks become more and more fragmented or non-contiguous over time. And since Informix's data pages are far smaller than ZFS pages, right? The largest page size we have is 16K, and the largest write we typically do is 8 pages. So that's even not very big. ZFS pages can be multiple megabyte pages. And that means that any kind of rewrites to the same ZFS page, because you're writing to multiple Informix pages, may cause the same ZFS page to be relocated multiple times. And that will leave behind multiple dirty pages, ZFS pages that have to be cleaned and put back on the free list in the background, and that can affect your performance. Okay. Copy on write also causes SSDs to age prematurely. So while the fragmentation doesn't affect performance as much on SSDs as it does on spindle drives, um, rewriting the data to a new location, which is going to cause, if there's already data there, is going to cause the SSDs to do copy on write themselves, because that's the way they operate. Is going to cause the SSDs to age a little more quickly than they normally would with a different file system. Also, ZFS maintains multiple checksums for every data block and metadata block, and modifies each up the metadata tree for every write. So there'll be multiple. One write may cause one data block to move, but it may also cause the metadata block and its parent to also be rewritten. So that may be cause multiple physical writes to disk, and multiple even more dirty pages have to be cleaned up in the background. So it is high overhead, but safety for your data is fairly good. ext3 and ext4 are essentially the same as the ext2 physically on disk, but with journaling added and different features. So ext3 and ext4 main advantage besides journaling over ext2 is that they can be extended or expanded without having to unmount them. So they can be expanded while they're mounted, which your administrators like. Data and metadata are both journaled, and ext4 and ext3 both use copy on write rewrites when journaling is enabled, and that causes chunks to, again, become less contiguous and more fragmented over time. Okay, and the idea that those copy on writes will cause the SSDs to age prematurely is also true for ext3 and ext4. ext4 by default and ext3 optionally have what's called write back enabled, and that causes single entry metadata journal entries to be written before the data block that they map. So remember, copy on write is going to cause the data block to be moved somewhere else. That means the metadata has to be updated to tell the file system where to find the new copy of the chunk or that extent of the file. And when that happens, the ext4 will write out the metadata before it writes out the modified data block. Okay, so that if the system crashes in between, you're essentially hosed, because the system is looking for your data on a page that doesn't really exist or may have other old data on it. And your data is actually where it originally was because it never got written out. Linus thought that was really, really stupid. Okay, I don't like the safety or the performance of ext3 and ext4, especially ext4, because I don't think, at least not the last time I checked, you couldn't disable the write back metadata rights. On ext3, you can disable journaling. We don't need journaling in an Informix system. That's what our logical logs and physical logs are for. They keep us consistent and prevent data corruption for the most part, and do the job better than journaling does, frankly. So we don't need the journaling. VFS is proprietary. It's only available on certain systems. So we're going to skip over that. XFS is metadata only journaling. and it writes the journal before the data, but it uses a dual entry journaling system. So the old journal page is still on disk and still available to the file system. So if the data doesn't get written out, the file system will discover that after the crash when it recovers, and will simply restore the old journal page and delete the new one. So overhead on it is very low and safety is very good. Um, okay. If you have any questions, pipe in. Um, Tom, if you can watch for hands up because I can't see anything, let me know. Let's talk about RAID
Absolutely.
levels, one of my favorite topics. Thank you. So just a quick review. RAID 0 is striping only. We take multiple disks and tack them together to build a larger logical drive that spans all of the drives in the array. Data is written sequentially round robin to the drive. So block 1 will be on drive 1, block 2 will be on drive 2, block 3 will be on drive 3, and then block 4 will be back on drive 1 if there's, let's say, a 3-drive array. Okay. RAID 1 is simply mirroring. So you have 2 drives or more. That is possible to have more than 2 drives in a mirror set. And all the data is written typically for hardware mirroring is written in parallel to both drives at the same time. Some software mirrors like Informix is built-in mirroring right to the drive sequentially. So some of the write performance on software RAID 1 may not be as good as it is on hardware RAID 1, right, where both writes are happening concurrently in parallel. RAID 01 and RAID 10 are 2 ways to combine RAID 0 and RAID 1 to get the redundancy of RAID 1 and the size expansion and parallelism from RAID 0. Because one of the advantages of RAID 0 is you can read from all of the drives in the array at the same time and essentially multiply your IO rate. And you can write to multiple drives at the same time, reducing contention and increasing your write throughput as well. So RAID 01 and RAID 10 combine the 2 features of RAID 1 and RAID 0. The difference is the order in which the different RAID is applied. In RAID 01, we apply RAID 0 first and build 2 or more parallel arrays of 2 or more drives each, right, that have a larger capacity, and then we mirror those 2 stripe sets together, those 2 RAID 0 sets together. In RAID 10, we do it the other way around. We build n mirrored pairs, right, and then we stripe those mirrored pairs together. There are advantages to RAID 10 over RAID 1. Performance-wise, they're nearly identical. It would be hard for you to show performance the other in general. For really heavy random writes, RAID 10 has a slight advantage. The big advantage of RAID 10 is in recovery. It recovers much more quickly than RAID 01. And RAID 01, you have the problem that if one drive is unavailable, you have to rebuild that entire side of the mirror. And that puts you at risk if another drive fails on the active side of the mirror before you can rebuild the other side. And rebuilding the other side takes much longer because you actually have to rebuild every single drive in the array, even if only one drive crashed. Whereas in RAID 10, only the mirrored pair that lost the drive has to be rebuilt. So performance is in the 80% or more of normal performance when the dead drive was still online. Okay. Then we get to the parity arrays, RAID levels. RAID 1, RAID 2, RAID 3, RAID 4 are no longer used. There are some controllers I've seen that implement RAID 2, but not many anymore. So we'll kind of ignore them. RAID 5 is probably the most popular RAID level. There's 1 extra drive per array, so think of a RAID 0 stripe set with 1 extra drive that's essentially used for parity. But unlike RAIDs 2, 3, and 4, the parity is not on the 1 drive only, but the parity is distributed across the drives. Right, so if let's say you have a 5-drive RAID 5 array, that increases your storage to 4 times the single disk, the 5th drive. The capacity of the 5th drive is used for parity. But block 1 will be written to drives 1, 2, 3, and 4, and RAID 5 will have a parity block. Block 2 will be written to drives 2, 3, 4, and 5, and drive 1 will have the parity block. right, etc. So the parity block rotates around the drives. Um, so that if you lose a single drive, you'll have to recover only 1/5 or 1/nth of your data from the parity on the other drives. Okay, and for some blocks, the parity will be what was lost, and so we just have to rebuild the parity on the replacement drive. There are problems with RAID 5. I do not recommend it. In fact, I don't recommend any of these, but that is what it is. Again, RAID 5, like RAID 01, if you lose 2 drives, your data is hosed. It's gone. There's no way to recover your data at all. So some of the ways of getting around that were the invention of RAID 6, which is essentially RAID 5 with a second parity drive that allows you to recover from 2 lost drives, up to 2 lost drives. Obviously, if you lose a third one, you're just as hosed. Um, okay, and parity rotates on both parity blocks, rotate around the same way they do on RAID 5. RAID 51 is really weird. Take a RAID 5 array and mirror it with another RAID 5 array. So it's kind of like RAID 01 again. It has all the problems RAID 01, plus all the problems of RAID 5, which include very slow write performance compared to RAID 0. Okay? And RAID 61, which is even dumber in my mind, which just takes 2 RAID 6 arrays and mirrors them together. 2 new ones that I heard about recently that I didn't know about before, RAID 50 and RAID 60. Basically take a bunch of 2 or more RAID 5 arrays or RAID 6 arrays and stripe them into a RAID 0. The only difference between that and just a bigger RAID 5 or RAID 6 array is that um, you have parity for subsets of the array. So if you lose 1 drive in one of the arrays that you've built this RAID 50 array or RAID 60 array from, you're only rebuilding part of the array, and performance during recovery is a bit better. And recovery will be a little bit faster. Okay, it still has all the problems of other RAID 5 and RAID 6 systems. So basically, my mantra is still no RAID 5, no RAID 6, no RAID 51, 61, 50, or 60. And I've been complaining about RAID 5 forever, but as I note here, the storage industry is coming around and beginning to realize that I've been right all these years. And I have been writing on the evils of RAID 5 since 1995, I think. So it's been a while, all over the internet, and people do quote some of what I've written, and people complain about it too. It's a lot of fun. But the problem, what the industry has discovered is that if the possibility of losing a second drive during recovery is 4 times more likely in practice than the statistics and the failure rates would predict. So while the supposed safety of RAID 5 is predicted on a particular drive failure rate that the manufacturer proposes, the actual failure rate of a second drive in an array that already has lost 1 drive is 4 times more likely. And we'll talk about one of the reasons why in a minute. And note that server grade drives, those very expensive drives that you get from your SAN vendor, while they're several times more expensive than commodity drives you can buy at Staples, right, or on Amazon, are 2 and 3 times the price, their failure rate is nearly identical. It is 1 order of magnitude better, which is not all that great. Atomic writes to multiple drives in a RAID 5 or RAID 6 array are not guaranteed. Okay, so when you write a block to one of the RAID 5 drives and it now has to read all the other drives and write to the parity block, those 2 writes are not atomic. So the system could crash. You could have a power failure in your SAN or your array, or lose a controller, and essentially your data is going to be hosed because the parity will not have been written, but the data will have. So you now have an array that can't be recovered because the parity is going to recover data that is out of sync. Larger drives take longer to rebuild. That increases the risk of multiple drive failure, right? When over what used to happen when drives were relatively small. A recent study concluded that drives over 1 terabyte, and we've got drives I think up to 16 terabyte today, maybe bigger, are statistically likely to suffer from multiple bit dropouts, because the number of bits on the drive exceeds the bit failure rate of the drive. Because when the drives got bigger, the bit failure rate didn't decrease; it actually increased. Um, so as I said, you're statistically likely to lose data on a RAID 5 array using larger drives. And SSD flash drives, they suffer from bit rot, just like spindle drives, just for a different reason. They also suffer from cosmic ray damage. I know that sounds science fiction and weird, but it is true. Both spindle drives and flash drives suffer from cosmic ray damage. Okay, and more so if the flash drives are written to very frequently as they are in database applications. In file system applications, that's less important. All in all, the errors observed at CERN, right? That's the Large Hadron Collider in Switzerland. Um, they studied silent corruption because they were losing data all over the place. They have thousands and thousands of drives to hold the data that they collect, even from one experiment. And they discovered that the official rate, bit failure rate of 10 to the 16th bits in most drives, 10 to the 17th in some of the better drives, um, they actually observed failure rates closer to 10 to the 7th bits, one out of every 1 million bits. So that's pretty bad. There's a link at the bottom of the page that for a wiki that talks about some of this. This is new. I found this on a Dell webpage. Dell no longer recommends using RAID 5 for any business critical data. Yay, somebody came around. And of course, Dell is now one of the largest storage stand vendors in the marketplace. And they no longer recommend using RAID 5 because, as they said, RAID 5 carries higher risks of encountering unrecoverable drive errors during a rebuild and therefore does not offer optimal data protection. Yeah, that's what I've been saying for, I don't know, 35 years. So let's talk about CERN. They had this concern, they were losing data was getting corrupted. So they started experimenting as only physicists can to try and figure it out. And they beat the crap out of 1.5 petabytes of data on RAID 5 arrays and noticed data corruption. So they began to study the problem. One of the things they found out was that, which I've also said for many years, is that RAID controllers do not check parity when they read from a RAID 5 file system, right? Or a RAID 5 array. It only reads the one drive that contains the the block that's being read, and doesn't read the other drive, so it can't check parity, right? That would seriously impact performance, so they don't. And also the RAID controllers do not report problems on the disk level to the operating system. And most disks do not report recoverable errors to the controller. So the controller doesn't know there's a problem, the operating system doesn't know there's a problem, Informix doesn't know that there's a problem, and you've got what we call bit rot, right? You've got blocks on disk that are starting to lose their magnetism for a spindle drive, or chips on an SSD drive that are losing their ability to successfully read. And the drive itself silently reads that data over and over again until it gets the internal check bits to come out clean, and then it rewrites it somewhere else, hoping that that block is not also corrupted. But eventually you start to run out of those rewrite spaces. And the drive does not report that either, that it has run out of rewrite spaces, and will soon start returning that garbage. So this is from a paper. There's a link here to the CERN website where this paper is. But paraphrasing what it said there, CERN tested a program that they had developed that writes a 2 gigabyte file containing a special bit pattern and reads the file back and compares the patterns. The program was deployed on 3,000 drives, or arrays actually, and run for 2 hours for 5 weeks. Every 2 hours for 5 weeks, running over 3,000 nodes, and they observed 500 errors on 100 of those nodes. That's a significant problem. So they found that 80% of the errors they were finding they could trace back to disk firmware bugs, drives that had firmware that hadn't been recently updated, and where there were bugs in the older firmware that they were running. Okay, but when was the last time your drive manufacturer called you up and said, "Hey, those drives you've got need a firmware update"? Doesn't happen. 10% of the errors they traced to memory cards that were incompatible with the system boards. Somebody had plugged in a memory card that was not the right memory card. Okay, another problem that's fixable. But RAID 5 could not correct any of those errors, nor could it correct the remaining 10% of the errors, which they attributed to bit rot, and they attributed to cosmic ray damage. Please note that CERN was experiencing cosmic ray damage, and their data center is underground. None, yours is not. Yours is under a tin roof. So why use RAID 10? It is safer from bit rot because it doesn't copy garbage from drive to drive, right? You always, when you're writing to a RAID 10 array or a RAID 1 mirrored pair, you write to both drives from the original data, whether they write, it's hardware and is writing in parallel, or it's a software RAID that's writing them sequentially. It's writing the original data to both drives. Whereas in a RAID, any kind of parity RAID situation, the parity is written by rereading data that's on disk. So you may be writing a block to drive A with parity on drive 6, and drives 2, 3, drive 1 and then drive 6, drives 2, 3, 4, and 5 have to be read, and those the new data from drive A and all the old data from drives 2 through 5 are used to calculate the parity that's written to drive 6. If some of that data on drives 2 through 5 has been corrupted, and again, the RAID controllers don't check parity on read, so you are now creating parity from garbage. And if you lose another, let's say drive 2, you're going to rewrite it with garbage. And your data is now corrupt on 2 drives, the one that had the original corruption that screwed up the parity, and the drive that you just recovered to where you've written garbage to again. Now you have 2 drives worth of garbage. Okay. They also determined that they were at least 75% more susceptible to data loss from a second drive, not less. That's a typo. I'm sorry, RAID 10 is 75% less susceptible to data loss from a second drive failure, because you only lose data if the particular drive that failed is the mirror of the first drive that failed. But if you have a 10 pair array, right, you have 9 other pairs that are perfectly fine, and you could lose 9 drives on top of the first one, and never lose data, only if one particular drive fails, right? Also, recovery time is 80% faster on a RAID 10 array than a RAID 5 array with equivalent storage, or a RAID 6 array with equivalent storage, because the performance degrades typically less than 10% during recovery, depending on how many drives you have. So for a 5-drive array versus 80% performance loss on a 6-drive RAID 5 array, a 5-pair RAID 10 array will only suffer about 6% performance degradation. Okay, and mostly it's only if you need data that's on the drive that's being rebuilt. Also, since you're only rebuilding one drive and not an entire array of drives, recovery is a whole lot faster. Okay. RAID 10 also gives you 100% increase in write performance. It writes twice as fast as even a RAID 0 array, but much more than 100% faster than a RAID 5 array, without adding a lot of expensive cache memory to the SAN, right? People go, oh, but RAID 5 uses fewer drives, I save some money. Yes, but to get the performance you need, you have to put in cache memory on that SAN, and that's more expensive than the drives. So I don't see the gain there. You can reduce and minimize the danger of firmware bugs and other hardware problems and of losing this specific second drive of a mirror pair if you build each mirrored pair from drives from 2 different manufacturers' lots. Okay. I have a story about when I was at Bloomberg and we lost 200 drives over the course of a couple of weeks because of a hardware in the drives. And it started trashing drives before we could replace them all with new ones. There was a paper presented at FAST in 2007 by Google Google reported that the probability of losing data during recovery from unrecoverable errors, that's our bit rot, on a RAID 5 array of 8 terabyte drives was over 98%. That means you were a little less than 2% likely to recover safely. That doesn't sound good to me. And that's from Google. They use, again, like CERN, millions of drives. Um, so this is a link to the page on my website where you can find the paper I wrote many years ago on why you should not be using RAID 5. I do update it periodically. I think the last update was actually last year. So that's there. You can download the PDF copy of it. It's on my website. You just go to askdbmgt.com, and you can click on the menu for other things, and you'll see it there. Also, there's a website called barf.com, BAARF, which is an acronym for We Hate RAID 5, where a whole bunch of people from a whole bunch of different countries and organizations um, have come together to warn people about RAID 5 and RAID 6 and all other parodies. That's it. Get out of here and stop sharing and see if we have any questions. David Stesh, you're welcome. Yes, David. Most Linuxes also do support BTRFS, and it is the default on SUSE and a couple of other distributions. I have not tested BTRFS with Informix myself. The last cross file system performance testing I did, I think was in 2015, and BTRF wasn't common back then, so I did not include it. But it would be interesting to do that.
So, Art, what are your thoughts on RAID 5? Now, seriously, and I apologize if you said this because my headset cut out for a moment. The other thing, that with server level drives is
Mhm.
you normally buy them all at once, and so you're usually buying them all in a batch. So
Yep.
if there's a problem with hardware, odds are which is why a lot of times you get multiple drive failures in a quick amount of time in a data center
Hmm.
or another region, I should say.
It is a problem because you want to always build your mirrors from um, multiple manufacturers' lots, right? Because there could be a bug in an entire lot. That's what
Yep.
happened to us at Bloomberg. We got a call from at the time it was Digital Equipment Corp, which is long gone, that their arrays were built with IBM OEM drives, and IBM had called them to let them know that an entire manufacturer's block, a lot of drives had spindle issues, bearing issues, where the spindles would seize after, I think it was 20,000 hours or something like that. And that we were getting close to that, according to the reports they were getting um, electronically from the arrays. So they were shipping us a batch of new drives, and we should start replacing them. And we did. But as I said, some drives failed before we could get that done. Fortunately, unfortunately, those were all RAID 5 arrays. Fortunately, the only ones that failed were developer drives on the development machines that had source code, which was already backed up and archived elsewhere, so we were able to recover. The database file systems that were built on drives that were at risk were successfully replaced before we lost any data. But it was the final leg on Bloomberg listening to me and changing all of their databases to RAID 10. After that experience, it was very scary. Took us 3 weeks to replace all the drives, because you can't take a system offline in the middle of the trading day. But that's what we had to do.
One other thing on there is there was an HP bug a couple of years ago with their solid state disks where, due to a firmware problem, the disks themselves would fail automatically at, I believe it is 40,000, I'm just Googled it, 40,000 hours, would automatically fail. So
Hmm.
it wasn't even a hardware failure in terms of something going bad. It was a software bug in the firmware.
Yeah.
So you
Yeah.
buy, all of them would fail at the exact same time.
Oh, lovely.
Yeah.
Yeah,
So
it's and then nothing's going to save you from that. And again, if you were building those drives from those arrays from drives from different lots, maybe the one lot had the older firmware that didn't have the bug, or newer firmware that doesn't have the bug, and you're safer.
yeah.
Let me see. Sada asks, what mirroring used mostly in sand vendors? Most sand vendors will offer you RAID 5 or RAID 10. RAID 1 is typically supported, excuse me, um, and RAID 0 as well for most of them. And then some like HP and others offer weird hybrid systems that automatically migrate your data from RAID 10 to RAID 5 if it starts to fill up, drive back, or multiple drives back, to put more data on without you having to buy more drives. To me, suddenly finding out that my array changed itself from RAID 10 to RAID 5 would scare the crap out of me. Yeah.
So does
All right.
anyone have any other questions? All right. Thank you so much, Art. And we're going to